Welcome to our deep dive into one of the most fascinating phenomena in the universe, black holes. These cosmic monsters warp the fabric of spacetime and challenge our understanding of the cosmos. Today, we'll be answering 10 questions you might have about these mysterious cosmic objects. From their formation to the mind-bending implications for time travel, we'll journey to the edge of the unknown. So, buckle up, space cadets. Let's begin our cosmic quest. Imagine a place where gravity is so strong it overpowers all other forces in the universe. A place where the very fabric of space and time is warped to its breaking point. That, my friends, is a black hole. In the simplest terms, a black hole is a region in space-time where matter has been squeezed into an incredibly small space. This extreme density creates an immense gravitational pull, so strong that nothing, not even light, can escape its grasp. It's a region with a defined boundary, called the event horizon. Cross the event horizon and there's no turning back. Black holes come in different sizes, from stellar mass black holes to supermassive black holes lurking at the centers of galaxies. But no matter their size, they all share this fundamental property, an inescapable gravitational pull that warps the very fabric of space-time. The universe can be a chaotic and violent place, especially when it comes to the death of stars. And it's from these cosmic death throes that most black holes are born. Imagine a star much more massive than our sun, reaching the end of its life. It's burned through all its nuclear fuel, and the outward pressure from fusion can no longer hold back the immense inward force of gravity. What happens next is a spectacular collapse. The star implodes, collapsing in on itself with incredible force. This collapse triggers a supernova, a massive explosion that can outshine an entire galaxy. If the star is massive enough, the core continues to collapse even further, crushing down into an infinitely small point known as a singularity. This singularity, shrouded by the event horizon, becomes a black hole. However, the universe is filled with stars far more massive than our sun, and it's from their dramatic demise that these cosmic monsters, the black holes, emerge. Fasten your seatbelts, folks, because we're about to take a hypothetical trip to a place where the laws of physics get a little weird. Let's imagine what might happen if you were to fall into a black hole. Now, I say hypothetical because, well, no one has ever taken a black hole plunge and lived to tell the tale. As you approach the black hole, the first thing you'd notice is the intense gravitational pull. You'd start to accelerate faster and faster towards the event horizon, the point of no return. Because of the extreme gravity, time itself would start to slow down for you relative to an outside observer. To someone watching from afar, you'd appear to slow down as you approach the event horizon, eventually freezing in time. But from your perspective, you'd continue to fall, experiencing the effects of the black hole's gravity firsthand. The gravitational pull on your feet would be much stronger than on your head, stretching you out like spaghetti in a process aptly named spaghettification. Eventually, you'd be stretched and torn apart, your atoms ripped apart as you cross the event horizon and enter the singularity, the point of infinite density at the heart of the black hole. Now I know what you're thinking, black holes sound like cosmic vacuum cleaners sucking up everything in their path. And while their gravity is undeniably powerful, the idea that they're out there gobbling up entire galaxies is a bit of a misconception. You see, black holes don't wander the universe, randomly sucking up everything in sight. They're bound by the same laws of gravity as everything else. Think of it this way, if our sun were suddenly replaced by a black hole of the same mass, Earth's orbit wouldn't change a bit. We'd be in for a world of darkness, yes, but we wouldn't be sucked in. The danger zone around a black hole is primarily limited to its immediate vicinity, close to the event horizon. So while it's not impossible for a black hole to pose a threat to Earth, it's highly unlikely. Rest assured, Earth is safe from becoming a black hole snack, at least for now. Black holes, by their very nature, are invisible. They emit no light, making them incredibly difficult to detect directly. So how do we know these cosmic enigmas even exist? Well, like a detective searching for clues, astronomers have to rely on indirect evidence to prove their existence. The most compelling evidence comes from observing the effects of a black hole's intense gravity on its surroundings. One way is by observing the motion of stars. Stars orbiting a black hole behave as if they're waltzing with an invisible partner, their paths influenced by the immense gravitational pull. Another clue comes from X-ray emissions. As matter falls towards a black hole, it heats up to millions of degrees, emitting intense X-rays. By studying these X-ray signatures, astronomers can infer the presence of a black hole. These observations, along with other scientific data, provide overwhelming evidence for the existence of black holes. Imagine a boundary in space, a point of no return, a place where the pull of gravity is so strong that not even light, the fastest thing in the universe, can escape. This, my friends, is the event horizon, the defining feature of a black hole. Think of it like a waterfall. As you approach the edge, the current gets stronger and stronger. Eventually you reach a point where the water is flowing faster than you can swim. That's the point of no return. The event horizon of a black hole is like that waterfall, but instead of water, it's gravity that's pulling you in. Once you cross this boundary, there's no escaping the black hole's gravitational grasp. You're destined to journey towards the singularity at its heart. The event horizon is a boundary in spacetime, a place where our understanding of physics is pushed to its limits. Black holes are often portrayed in science fiction as gateways to other dimensions or time machines that can transport us to the distant past or future. But can these cosmic oddities really manipulate time in such a way? Well, according to Einstein's theory of general relativity, it's not entirely out of the realm of possibility. Gravity doesn't just warp space, it warps time as well. The stronger the gravity, the slower time flows. And since black holes have the strongest gravitational pull in the universe, they can, in theory, significantly distort the flow of time. One hypothetical scenario involves traveling near a black hole and returning to Earth to find that far more time has passed than you experienced. Another mind-bending idea is the concept of wormholes, theoretical tunnels that could connect two different points in spacetime, potentially allowing for travel between different universes or points in time. However, it's important to note that these are just theoretical possibilities. The extreme conditions around black holes make it difficult to say for sure if time travel via black holes is truly feasible. The interior of a black hole is one of the greatest mysteries in the universe. It's a place where our current understanding of physics breaks down, and we have to rely on theories and speculation. At the heart of a black hole lies the singularity, a point of infinite density where all the matter that falls into the black hole is compressed into an infinitely small space. Some theories suggest that the singularity is a point where all the laws of physics cease to exist, a place where space and time have no meaning. Others propose that the singularity could be a gateway to other universes or dimensions. But here's the catch: we can never actually observe what's inside a black hole. Even if we could send a probe into a black hole, it could never send back any information. So for now, the interior of a black hole remains one of the most tantalizing mysteries in the universe. Black holes, despite their reputation as cosmic vacuum cleaners, play a surprisingly constructive role in shaping the universe around them. Their immense gravity, while destructive at close range, can influence the formation and evolution of galaxies on a grand scale. Think of a black hole as a conductor leading a cosmic orchestra. Its gravity dictates the movements of stars and gas clouds, influencing their orbits and interactions. For example, supermassive black holes found at the centers of most galaxies play a crucial role in regulating star formation. They can both trigger star birth by compressing surrounding gas clouds and quench it by releasing powerful jets of energy that heat up and disperse gas. These jets, launched from the accretion disks of materials swirling around black holes, can extend for thousands of light years, influencing the evolution of entire galaxies. So, while black holes may seem like destructive forces, they are, in fact, integral parts of the cosmic ecosystem. Just like there are different types of stars, from tiny red dwarfs to massive blue giants, black holes also come in a variety of sizes and masses, each with its own unique characteristics. The most common type is stellar mass black holes, formed from the collapse of massive stars. These black holes typically have masses a few times that of our Sun and are scattered throughout galaxies. Then there are the behemoths, the supermassive black holes. These cosmic giants lurk at the centers of most, if not all, galaxies, including our own Milky Way. With masses ranging from millions to billions of times that of our Sun, They exert a powerful gravitational influence on their host galaxies. But there's a third type, a sort of middle child in the black hole family, intermediate mass black holes. The study of different types of black holes provides valuable insights into the life cycle of stars, the evolution of galaxies, and the fundamental nature of gravity itself. Thanks for joining us on this journey through the cosmos, exploring the enigmatic world of black holes. From their formation to their potential as time-bending cosmic gateways, black holes continue to captivate our imaginations and challenge our understanding of the universe. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating science content. And remember, the universe is full of wonders waiting to be discovered. Stay curious, and we'll see you next time.